write down the balanced equation for the fertilizer Q. Let's have a look at fertilizer Q there down. Okay, and in this case, what is it that we really used in order to form fertilizer Q? Can you see that you needed something from this right-hand side of the flow chart and something on the left-hand side of the flow chart? So you ultimately used compound A and you let it react with compound C in order to form fertilizer Q. So you definitely have to know what compound C is and what compound A is in order for you to know what this fertilizer is all about. And if you look at that, you will find that you are having different substances there, and when you write that down, you will have found that here. Remember, you had H2, S2, O7, and then you react it with H2, O, not SO4, but O, H2O. Something very funny that you will find being formed. You know, this compound C here, H2SO4. Funny, eh? Remember, you used sulfuric acid to form pyrosulfuric acid, but you need that pyrosulfuric acid to form sulfuric acid again. So this is just something else very unique. And who discovered that? Really, scientists are very good. So we have here H2SO4 again as a product. Here it was not a product, it had to be used, it was coming from somewhere. Right, and then this time, remember we said we've got nitrogen and hydrogen, and I think we once came across that, N2 plus H2, where you form NH3. It is not balanced. If you've got to balance that, remember we have to put 2 in order to make them like those, and the hydrogens now become 6, but you can't put 6, but instead you put 3. But the most important thing that we need to know is that this compound here is nothing else but ammonia, because that is the process that was there. And now for a fertilizer Q to be used, you have to react this ammonia with sulfuric acid. And I don't know whether you are aware that, guys, a fertilizer somehow is some sort of a salt, an ionic salt, because usually that's where you have a reaction between a base and an acid. In this case, this is your base and that is your acid. So that's one thing that is always there. A reaction between an acid and a base will always result in salt and water. So fertilizer Q is that salt that you will form. And let us check how we can write that down. We have ammonia, we have sulfuric acid, and as I say, we need to have salt and water. And at other times, you find that because of, the way this is very strong, we can even have, a way of finding just one thing formed out of that. And that fertilizer can come up on its own as NH4. Remember the charge of NH4 plus. It's a plus. And we have here a sulfate. And remember the charge of a sulfate is 2 minus. Now if this is a minus and this is 2 minus, what is it that we are going to have? We definitely have to have how many of these? 2 of them. Okay, so that is very important. This is called ammonium sulfate. So that is a salt that you are having, or a fertilizer that has been formed through this process. I just wonder whether we need to balance. Okay, Let us balance and check if that is balanced. Now, in this case, we are having here nitrogen is 1, and here we've got 2 of them, and then we have there this in order to balance those nitrogens, right? And then I said when you balance, please preferably balance hydrogen and oxygen the last. Then we go to sulfur 1, 1. Okay, then you can go for hydrogen or oxygen. When you have hydrogen, we have there on the left-hand side 6. It's not 5, guys. We multiply. 6 plus 2 is 8, and this side automatically is balanced 8. And let's go for oxygen. Oxygen, we've got 4 of them, and we've got 4, so everything is sorted. We are having a balanced chemical equation here. Right, so it is, like I say, really it is always wise and advisable to balance hydrogen and oxygen the last.